Good morning, class 10th. Today we are going to do section formula from coordinate geometry. But before I start the exact formula, I'd like you to remind you of a theorem which we had done earlier in junior school, because this is going to be implemented into this, so you must be aware of this theorem. And the theorem was, which I have drawn here, and I'll explain it to you. Like there are two or more than two parallel lines. I have taken three parallel lines. Suppose I say LS, MT and NU are three parallel lines. They are three parallel lines. There is a transversal. Transversal is any straight line cutting parallel lines or any two or more than two lines. So it's a transversal. If a transversal cuts the intercept LM and MN on these lines. LM and MN are intercepts, portions cut on these lines, and if LM is equal to MN, if LM and MN are equal, then any other transversal anywhere will cut equal intercept on them. That means ST will be equal to TU. ST will be equal to TU. In another manner also, we can say if the ratio of LM is to MN, whatever is the ratio between LM is to MN will be the ratio of ST is to TU. That is the basic theorem which we are going to implement in this. And before I started, I want to recap the whole theorem once again for you. Because what we used to do, if you remember, we used to draw lines like this. And we proved these two triangles to be congruent. We proved these two triangles to be congruent. How did we prove them to be congruent? If LM was equal to MN, suppose I take it as A and B. So LSAM becomes a parallelogram. Similarly, MTBN becomes a parallelogram, because this line is parallel to this, is parallel to this. And I'm making this line parallel to this and this line parallel to this. So obviously this figure LSAM as well as MTBN becomes parallelogram. They become parallelogram, and opposite sides of parallelogram are always equal. Opposite sides of the parallelogram are equal, so LM will be equal to SA and MN will be equal to TB. And since LM and MN are equal, so SA and TB will also be equal. They will also be equal. And another thing is that this angle is equal to this angle is equal to this angle, so this angle is also equal. And also this angle will be equal to this angle. Why? Because these are two parallel lines and a transversal cuts them, so these are corresponding angles. So two angles and one side of this triangle is equal to two angles and one side of this triangle. So triangles are congruent to each other. And if the triangles are congruent to each other, then their corresponding sides will be equal. That means ST will be equal to TU, and that is what exactly we had to prove. That if a transversal cuts equal intercept on parallel lines, then any other transversal will also cut equal intercept on them. Intercepts are only possible if there are three lines or more than three lines are there. So this intercept is equal to this intercept. Then we have to prove ST is equal to TU, which I have proved. Or if I say LM is equal to MN, the ratio of LM and MN is same, then the ratio of ST is to TU will be also same. Now let us see this. What is the section formula and what we are discussing in this. There are 2 points given on the two-dimensional plane, P and Q. You can see in the figure, P and Q are 2 points on the two-dimensional plane. The coordinates of P are x1, y1. The coordinates of Q are x2, y2. The coordinates of P are x1, y1. The coordinates of Q are x2, y2. If I drop a perpendicular from P to x-axis and from Q to x-axis, I get PA and PC. That means the length OA is x1 and the length OC is x2. length OC is x2. There is any point in between P and Q. We are taking the point, it is internal bisector, internal divider, not bisector. Bisect means divide into two equal points. R is not dividing P and Q in equal part, but R is dividing in the ratio of m:n. R is dividing the line PQ in the ratio of m:n. And let the coordinates of R be x, y. That means OB will be x. I dropped a perpendicular from R to x's. Now PA, RB and QC are perpendiculars from point P, R and Q on x-axis. They are perpendicular to the same line. That means PA is parallel to RB is parallel to QC. Why? Because all these lines are perpendicular to the same line, and if the lines are making the same angle to the same line, then they are parallel to each other. That is what the definition of parallel lines is. So PA is making an angle of 90 degree with the x-axis, RB is making an angle of 90 degree with x-axis, and QC is making an angle of 90 degree with x-axis. That means PA, RB and QC are parallel to each other. They are parallel to each other. That means these are three parallel lines. PA, RB and QC are parallel lines. Another thing is that this transversal PQ divides it in the ratio of m:n. That divides the ratio of PR is to RQ is how much? PR is to RQ is given as m/n. The theorem which we just now discussed with you, equal intercept theorem, that if there are three or more than three parallel lines, if there are two or more than two parallel lines, and if a transversal cuts equal intercept on them, then any other transversal will also cut equal intercept on them. Or if any transversal cuts it in the same ratio like m:n, then any other transversal will also cut it in the same ratio. That means it will be equal to AB upon BC also. This will be equal to AB upon BC. That is important to understand. If there are three parallel lines, a transversal PQ cuts PQ by a point R in the ratio of m:n, then this transversal will also cut these parallel lines in the same ratio. That is, AB and BC will be of the same ratio as PR and RQ are. PR upon RQ is m:n, so AB upon BC will be also m/n. Now let us find out, as I have written, that OA is x1, OB is x, and OC is x2. We calculated what is the value of AB. I calculated what is the value of BC. And I am saying AB upon BC is m:n. AB upon BC is equal to m/n. I calculated what is the value of AB, x minus x1. And BC has been calculated as x2 minus x. x2 minus x is equal to m/n. Cross multiply. Cross multiply and let us see what do we get. We'll get n into x minus n into x1 is equal to n into x2 minus mx. Now transfer x terms on one side. Transfer x terms on one side, nx plus mx is equal to mx2 plus nx1. Or if you take x common, it will be n plus m. It will be equal to mx2 plus nx1. So x will be equal to mx2 plus nx1 upon m plus n. Copy this down, go through this. Now we had dropped perpendiculars from P, R, Q on the x-axis to get the x-coordinate. For getting y-coordinates, we are dropping perpendiculars from P, R and Q on y-axis. PD is perpendicular to y-axis from point P, RE is perpendicular from point R on y-axis, and QF is perpendicular from Q onto y-axis. If these are again perpendicular, then PD is parallel to RE is parallel to QF, because all these three lines are perpendicular to the same line. They are making the same angle to the same line, and that is the property of parallel lines. So these lines are parallel to each other. Now in this, like in this case, when we drop perpendicular to x-axis, we had calculated x-coordinate. When we have dropped perpendicular on y-axis, we will calculate y-coordinate. Like OD is y1, OE is y, and OF is y2. And we calculate then ED as y minus y1, FE as y2 minus y. And again the same principle is applied, that if there are two or more than two parallel lines are cut by a transversal, like here PD, RE and QF are parallel lines, and a transversal PQ cuts the intercept in the ratio of m is to n, then any other transversal to these lines will also cut intercepts in the same ratio. That means ED upon EF will also be m is to n, will be also m is to n. And based on this, we will calculate the y-coordinate. We calculated the x-coordinate already, x-coordinate of the point R. Let me calculate the y-coordinate of the point R. And what is the y-coordinate of the point R? Like we said, ED upon EF, ED upon EF will be m is to n. We are saying ED is y minus y1 upon y2 minus y is equal to m upon n. Or what will we do? N into y minus n into y1 will be equal to m into y2 minus m into y. I'll bring the y terms containing y, similar terms you bring on one side and the other terms you transfer on the right hand side. So I'll transfer the term containing y because I have to find y onto left hand side. It will be ny plus my is equal to my2 plus ny1. I'll take y common, m plus n or n plus m, one and the same thing, is equal to my2 plus ny1, or y will become my2 plus ny1 upon m plus n. For your benefit, I'll write the x-coordinate also. That is mx2 plus nx1 upon m plus n. These are the coordinates of the point which divides the line PQ, whose endpoints are x1, y1, x2, y2 in the ratio of m is to n. The thing which has to be noticed is this side ratio m. This side ratio m, when I am calculating the x-coordinate, when I am calculating the x-coordinate of R, this m, ratio m, is not multiplied by x1, but it is multiplied on the other side. M will go to this side. This is very important to remember. M into x2, m into x2. Similarly, when I am multiplying n, I am not multiplying it to the closer x, but the farther x. N into x1. mx2 plus nx1 upon m plus n. So the ratio m will be multiplied with the coordinates of q, and n will be multiplied with the coordinates of p. They are m will be multiplied, m and n both will be multiplied with the coordinates of the point which are further away from m, not closer to m or to n. like m is not being multiplied by x1, y1. This is a way to remember. This is a way to remember. N will be multiplied on the farther side, x2, y2. Similarly, n will be multiplied at this side. You can see here also, y coordinate is m by 2 plus ny1 upon m plus n. In the denominator, we have both places m plus n, and it is very simple to remember. M should multiply this side coordinate. If we are calculating x coordinate, then x coordinates will come here. mx2 plus nx1 upon m plus n. If I am multiplying, if I am getting y coordinate, then I have to take only y coordinate like m by 2 plus n by 1. So if I am calculating the x coordinate of point R, then you will have to pick up the x coordinate of Q and x coordinate of P. When we are calculating the y coordinate of R, then we will have to pick up the y coordinate from Q and y coordinate from P. But the only thing which you have to remember is the distance between M and the point should be larger than smaller. Like I'm not going to multiply M with P or N with Q. I'm going to multiply M with the coordinates of Q and N with the coordinates of P, which are further away. Farther away, or you could say the distance is more. The distance between M and Q is more than the distance between M and P. So we will choose the point Q, not P. And when you are multiplying with N, you are not going to choose Q but P, because this P and Q are not unique. This could be some other point, AB also. This could be AB also. So it doesn't matter. And M and N is also not unique. It could be given some other ratio. You have to keep in mind that this ratio should multiply to this coordinate on the cross. This will go to this side, this will come to this side. This is called section formula. Here the point R is in between A, P and Q. We are not going to discuss external division where R will be outside the line PQ, because that is beyond your syllabus just now. We are only doing internal division, but in external division it is very simple. You just replace minus, 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 minus. That is all, nothing else. You replace the signs from plus to minus and you will get the external division point. But this is the formula for calculating the points, the coordinates of point R, which divides the join of x1, y1, x2, y2 in the ratio of m is to n. Now the next is I have x as mx2 plus nx1 upon m plus n, and I have y as m by 2 plus n by 1 upon m plus n. Now if R becomes the midpoint, of P and Q, then what happens? If R becomes the midpoint of P and Q, that means m is equal to n. For R being midpoint of PQ, m will be equal to n. That means either in place of m you put n, or in place of n you put m, one and the same thing. So let us see the midpoint, what it will become. It will be m is equal to mx2. In place of n I am putting m x1 upon m plus n. And y will be m by 2 plus m by 1 upon m plus m. We are putting in place of n equal to m. N and m both are equal. M and n both are equal. So let us see what do we get. M is common in the numerator. I get x2 plus x1 and I get 2m in the denominator. So m will cancel. Similarly here, if m is common, it is m2 y2 plus y1 and I get 2m. mm will cancel. So x will be x2 plus x1 upon 2, and y is y2 plus y1 upon 2. This is midpoint formula. This is midpoint formula. Midpoint formula. This is midpoint formula. We obtain the midpoint. We obtain the midpoint of PQ if the end coordinates are x1, y1 and x2, y2. So what we do is we add up the x coordinate, divide by 2. We add up the y coordinates of the end point, divide by 2. x1 and x2 are end points. x1 is the x point of P, and x2 is the x coordinate of point Q. So x2 plus x1 or x1 plus x2 is one and the same thing. They are commutative, addition is commutative. So x2 plus x1 upon 2, y2 plus y1 upon 2. So we get the midpoint. From section formula we get the midpoint formula. From the section formula we obtain the midpoint formula. The next application of this section formula is to find the coordinate of the centroid. We have already discussed centroid in detail. What is centroid of a triangle? We told you centroid is a point of concurrency of medians of the triangle. What does median of the triangle mean? If I join the vertex of the triangle, suppose A, to the midpoint of opposite side, D is the midpoint of BC. If I join A to D, similarly I join B to the midpoint of AC and C to the midpoint of AB. Then all these three line segments will pass through a point that will be concurrent at a point which is called centroid, which is called G. I am taking up one median only, not to complicate it to the figure to take other medians, because I understand that you understand medians very well as centroid. Centroid is the point of concurrence of median. Point of concurrence of medians. Point of concurrence of median. Concurrence means passing through one point, and we had already discussed that the median divides centroid divides the median in the ratio of 2:1. That is, AG is to GD is 2:1. Again we are using the property of, because it is internal division, we will use the section formula. Now I want to calculate the coordinates of D. How do I calculate the coordinates of D? Because it is the midpoint of BC. So let us calculate midpoint of BC. Midpoint of BC. We told you the formula for calculating the midpoint. Suppose this is midpoint of BC will be what? You add up the x coordinates of two ends, x2 plus x3, and divide by 2, and y2 plus y3 divide by 2. So the coordinates of D are x2 plus x3 upon 2 and y2 plus y3 upon 2. x2 plus x3 upon 2, y2 plus y3 upon 2. We add up the x coordinate, divide by 2. We add up the y coordinate, divide by 2. I have got the coordinates of point D. I have got the coordinates of point A. I want to find the coordinates of point xy. I know what is the ratio. AG is to GD. So I can calculate by application of midpoint formula coordinates of G. Coordinates of G, centroid. How will I calculate the coordinates of centroid? X will be, now we told you multiply the ratio with the farthest side. 2 will multiply this side, 1 will multiply this side. So 2 into x2 plus x3 upon 2 plus, what is it? mx2 plus nx1. 1 into x1. 1 into x1 upon m plus n, 2 plus 1. m is 2, n is 1. So this 2 will cancel with this 2. You will get x2 plus x3 plus x1 upon 3. Because 1x1 is x1, 2 is cancelled. So I can write it to be x1 plus x2 plus x3 upon 3. That means you add up the x coordinates of the vertices of the triangle, x coordinate, and divide it by 3, you will get the centroid of the triangle. Now if I want to calculate the y coordinate, this 2 will multiply it with this, 2 into y2 plus y3 upon 2 plus 1 into y1 upon 2 plus 1. And this will cancel with this, and you, what will you get? y2 plus y3 plus y1 upon 3. Or you will get y1 plus y2 plus y3 upon 3. It is very simple to remember. You add up the x coordinate, and you add up the x coordinate, divide by 3, you add up the y coordinate, divide by 3. The question is, determine the ratio in which the line 2x plus y minus 4 is equal to 0. There is any line which equation of the line is given as 2x plus y minus 4 is equal to 0, divides the line segment, divides the line segment AB, where the coordinates of A are 2 minus 2, the coordinates of B are 3, 7. He says divide the line segment. In what ratio does it divide? First of all, we have to calculate what is the ratio in which it divides. What is the ratio in which it divides? So let us see. Determine the ratio. Determine the ratio. Now what are we going to do? We don't know the coordinates of A and B. We don't know the ratio m is to n. So what are we going to do? Let us apply this section formula. What is the section formula? A, the x coordinate, here A is the x coordinate, m into 3, 3m, plus 2 into n, plus 2 into n upon m plus n. This is A. Now let us see what is B. B is m into 7, 7m, and this is minus 2n upon m plus n. Now how to find m and n? This coordinate A and B should satisfy this line 2x plus y minus 4 is equal to 0. Why? Because this point C is lying on this line. Satisfying means in place of x I should put this, in place of y I should put that in the equation, and let us try and do what we can. 2x, point AB, point C, AB should satisfy 2x plus y minus 4 is equal to 0. Why should it satisfy? Because it is lying on that point. This point is lying on this line, so it must satisfy. So let us substitute this. 2 into x, the x coordinate, A is the x coordinate, 3m plus 2n upon m plus n. 2x plus y. Y is 7m minus 2n upon m plus n minus 4 is equal to 0. Let us take m plus n as the LCM. It will become 2 3s are 6m plus 2 2s are 4n. Because m plus n is LCM, so it doesn't matter, that will remain the same. 7m minus 2n minus 4m plus n will be equal to 0. M plus n will cross multiply, it will become 0. M plus n is not equal to 0, so it's a positive number, we can multiply. Because it is dividing in some ratio, it will be positive. So if I cross multiply a non-zero number with a 0 number, I'll get 0. So 6m plus 7m is 13m plus 2n minus 4m minus 4n is equal to 0. 13m minus 4 is 9m minus 2n is equal to 0. That means you are getting 9m is equal to 2n. You are getting 9m is equal to 2n, or m upon n will be what? 2 upon 9. The ratio of m is to n. This ratio, this point C divides the line in the ratio of 2:9. 2:9. He did not ask you the coordinates of point C, but we can calculate the coordinates of point C as well. How? I'll show it to you just now. We calculated first of all the ratio m is to n, which came out to be 2 upon 9. He's not asking that question, but he can ask you a question to calculate, hence calculate the coordinates of point A and B. When I say m upon n is 2 upon 9, that does not mean m is 2 and n is 9. In a ratio, it is very important to understand that this does not mean n is equal to 2, n is equal to 9. Ratio means there can be multiple equivalent ratios which will be equal to 2 upon 9. That is why we generally say 2x upon 9x. Always attach an x. Then x can take any value, whatever value x can take. Suppose x takes 2, 2 2s are 4, 9 2s are 18, the ratio remains the same. If x is 3, 2 3s are 6, 9 3s are 27, the ratio remains the same. So we never, generally we try and put m is equal to 2x and n is equal to 9x, depending upon what the ratio is given, because generally we don't take a ratio to be m upon n is 2 upon 9 does not mean m is 2, n is 9. Though it will come correctly by putting that also, I know that, but it doesn't matter. We should do it correctly. Now, let us put the value of m and n and calculate the value of a and b. A was what? 3 into m. M is how much? 2x. Plus 2 into n will be, n is how much? 9x upon 2x plus 9x. So 3 2s are 6x, 9 2s are 18x upon 9 to 11x. It will be 24x upon 11x. So 24 upon 11 will be the x coordinate. And b will be what? 7 into n, 2x, minus 2 into n, 9x, upon 2x plus 9x. 7 2s are 14x, minus 9 2s are 18x, upon 11x. So minus 4 upon 11. X will cancel. So coordinates are 24 upon 11 and minus 4 upon 11. The coordinates of C are 24 upon 11 minus 4 upon 11, and the ratio m is to n is 2 upon 9. The ratio is 2 upon 9. He did not ask you to calculate the point C, but I calculated the point C because in some question he might ask you to finally calculate the coordinates of point M. That is why it is important to do that.